Hello everyone, this is Arun Ravindran. Recently, I gave a talk titled Higher Concepts and the Python Programmer. A lot of people liked this presentation and wished if a recording was available, and that's the reason why I'm recording this video. This presentation is basically about how I became a Python programmer, what are the principles I learned from learning other languages like Haskell and other functional programming languages, and what are those ideas which I can use when I'm programming in Python. First, let me go back in time and give you a little bit of context using history. As we all know, Rome was a great civilization, one of the greatest civilization at its time. In fact, a lot of people living in that era believed that Rome is living at the peak of its civilization, and there could be no better human progress in terms of culture, in terms of science, in terms of arts, and they really had a feeling that they reached the pinnacle of its popularity. However, as we see in the picture on screen, uh, the death of Marcus Aurelius, I think it's pronounced as Aurelius, I think. Uh, that was kind of the turning point which led to the decline of the civilization. The image is obviously not of the real Marcus, but of the actor playing Marcus in the movie Gladiator. And as we remember in this movie, very early in the movie, this scene happens and leads to a lot of events, which ultimately leads to the power falling into uh, the wrong hands, etc. So, why am I talking about this? Before that, who am I? As this is my channel. Most of you already know me. I'm a product manager at Unisys. I'm the author of the book Django Design Patterns and Best Practices, which has now reached its second edition. Yes, go buy it. And I write at my blog at arunrocks.com, and you can reach me on Twitter at arocks. I've been coding in Python since 1999 and been involved with Bangalore Python User Group for quite some time now. Uh, Let me take you back to my college days before I learned Python. So we are talking around the year 2000 when I started using Linux, and Linux used to be distributed in a bunch of floppy disks. So some of you know what's a floppy disk. It's basically a very minimal, very the precursor of a lot of storage mediums, and it just has 1.4 megabytes of storage. So, as you can imagine, an entire Linux system would need multiple sets of floppy disks. And imagine if you needed 15 floppy disks, you need to install them one after the other, and it used to be excruciatingly slow. And if your 13th floppy disk had a corrupt image, then you're like, oh my God, now I have to start all over again. And it used to be a big deal for us when Linux used to be distributed for free on some magazines like PC Quest or Digit, and it used to be available in the form of a CD-ROM. So the reason I say all this is the distribution used to be very minimal. It used to just contain the basic utilities, and uh, among the programming languages, only a handful of programming languages used to be available, like Perl or C and C++. Now, uh, Perl is a scripting language with a lot of similarities, or I would say Python is actually having more similarities with Perl because Python came after Perl. And I used to find it very cumbersome to program in Perl because it used to have a very terse syntax, and it used to have the principle of there is more than one way to do it, which leads to a lot of difficulty when it comes to reading other people's Perl programs. And I used to find it extremely difficult to do scripting or any other task in Perl. So in comes the alternative programming language, which was not very popular, but still gaining ground. And I used to have these favorites for underdog system or software applications. In this case, programming languages. And I found that Python was immensely readable. I didn't have a problem with the indentation-based syntax, and it used to be very obvious what the flow of the program is, one and what the intention is. And even after reading lots of lines of code, I was able to follow it, and it was almost like love at first sight. So Python instantly got me hooked, and I was finding more and more reasons to program in Python. And even my final year project in college had a large part in Python. I had to convince my professors, but they were reluctant, and eventually they agreed. And Python became, since then, my programming language of choice. Uh, Before I go to the good news and the bad news, uh, I need to say that I learned a lot of other programming languages on the way. And one of the most influential was Haskell. So Haskell has been with me since probably a couple of years after learning Python, and uh, it influences the way you think. It improves it gives more clarity in certain ideas, like which were not clear to me when I was learning another programming language called Lisp, which was considered to be one of the initial functional programming languages. And I'll come to that in a minute. So let me now fast forward and take you to the present, which is 2018. And recently, Python has been gaining extreme amount of popularity and leading in a lot of language surveys. So you might be seeing news like these, which came sometime last year, with that Python came out as the second most popular language on GitHub by the number of pull requests, and TOB, which is a leading indicator of programming language popularity based on ratings and based on surveys. It's approaching the top three. So Python is one of the top languages in TOB since August 2018, among with the big established programming languages for quite some time, like Java, C, and C++. So I should be careful in saying that, because Python is almost as old as Java. And it has been around for quite some time, but a lot of people don't know this, and it has avoided popularity for quite some time. But I think now it's slowly gaining the limelight. Another survey that showed the incredible growth of Python was Stack Overflow. Stack Overflow showed that Python is not only one of the leading languages, it is the fastest growing programming language at this point in time. So this is also interesting, considering how long Python has been around, and it has a significant base, but the base seems to be growing faster than all other programming languages. And recently, we had this article from IEEE in which they say that Python has been the top programming language in their last year's interactive ranking, and it still stays on top because of the new niches that Python seems to find. So Python is one of the most leading programming languages in the machine learning, artificial intelligence space, and Python recently has become popular in the IoT space with the MicroPython port of Python, and this becomes one of the new niches and maintains the popularity of Python in several diverse fields. So this makes us think, okay, the good news, we have the good news and the bad news here. The good news is, we are pretty much, being seen or being uh, known in most circles. A lot of people who I'm personally aware of, who are not aware of Python, are now finally asking me, how do I learn Python? where can I, get materials about learning it, and um, I'm seeing more and more projects using Python. The popularity is almost at its peak. The bad news is it cannot get any better now, right? And things can get only worse from here. It could be that the next year's ranking shows some other language like, say, Julia or Rust taking the top credits. Uh, so does this mean that Python is an ideal programming language? Of course, by no means. Python is without criticism. In fact, Armin, whose blog is shown on the image here, one of the prominent developers in Python, shows a lot of problems with Python and often writes criticism about Python. And here is here are some of the common criticisms. So, Python is notable for its lack of a type system. Uh, the, the global interpreter lock problem has been known for quite some time. You're not, Python does not allow you to multi-thread into the uh, Python interpreter due to the presence of a global interpreter lock, which allows only one thread at a time access to the interpreter. And mutable uh, variables is a very common paradigm in imperative programming, which means that variables can be changed once they are defined, and the old values are not retained; they are overwritten. And this could be a problem when it comes to concurrency, which we shall see in a minute. The other criticism is often duck typing. So Python is in fact strongly typed once you define what a variable is pointing at, but the typing is based on the behavior which is seen after you make a method call. So if it so the basic definition of duck typing is if it walks like a duck or quacks like a duck, then it is a duck. Basically, the implied behavior um, is what determines what type it is. And there is no static checking or static type checking at compile time, which makes it a very runtime dependent type system. The other criticism is often garbage collection. So if you're into applications which involve real-time systems, or even in near real-time systems like game programming, for instance, and you are in between a very intense action sequence and about to fire your opponent. Imagine the game freezes because the garbage collector suddenly becomes active and starts collecting the garbage, and which leads to if it's a multiplayer game, your opponents defeating you, etc. So in a lot of applications, garbage collection is considered to be um, a critical impediment to your performance, and it cannot Python is usually not used in such applications. Another criticism is that the concept of privacy is very loosely maintained. As you would know, a variable which has an underscore or double underscore in Python can be actually accessed. However, it is by convention that we don't access it. It's not truly private. It is just that we are not accessing something that is considered to be private, even though we can, technically speaking. Another interesting criticism is that Python's functional programming features are not that good because it does not allow um, complex lambda functions. This has been a very interesting criticism because the creator of the programming language Python is Guido, who is known as the BDFL or Benevolent Dictator for Life. He is not a big fan of lambdas, and it seems like he just gave in to a lot of demand and probably gave a little bit of concession by allowing one-liner lambda statements. However, a lot of people are not completely happy. So, this is not a comprehensive or complete list by any means. There are a lot more criticisms, but this gives you an idea. And to me, I feel every Python programmer should be aware of what the criticisms of Python are. Or for that matter, any programming language, if you are working in that programming language, it's extremely important that you are aware of its limitations. And this gives you an open mind to consider, for instance, if a programming language is not suitable for your applications, whether you should look at other programming languages or whether you should use some other capability of of the language that you were not using since you learned it. So this brings me back to the programming language, which really changed my thinking, Haskell. So my recommendation is if you are a Python programmer and if you have the time to pick up, or even if you have a very little time, like a weekend, to pick up a programming language, the language which I would suggest is Haskell. It's by no means going to be easy for you to learn Haskell or even to completely change your thinking paradigm to understand Haskell's paradigm and start working in that way. But I'm saying it is worth it. So the reason I say that is because the way Haskell works is like probably a much more purer form of functional programming, and a lot of concepts in functional programming are being seen in a lot of mainstream languages or even in newer languages like C sharp or F sharp or even Swift or Rust, etc. So many of the ideas from the functional programming world have been steadily coming into mainstream programming languages. And this is by no means, a coincidence. This is quite deliberate because functional programming languages are suited for certain applications. Like considering uh, we are moving towards a concurrency-oriented world where there we have multiple cores, we have multiple distributed systems, and they all need to work in a concerted fashion. So some of the functional programming ideas like purity and side effect freeness actually helps in this case. Uh, the interesting thing about Haskell is even though a lot of these ideas are getting into mainstream programming languages, they have this motto of avoid success at all costs, which means basically you should not it does not should not be taken in a very literal way that they don't want to be popular. It is more in the sense that we should not dilute Haskell's concepts or ideas because it becomes a more and more popular language. And we should keep the ideals or the original vision of the language intact, which I would say is a very good ideal to have or a goal to follow. So now comes to the more to the actual central theme of my talk, which is whether Python should learn from other languages. And I have been thinking a lot about this, because a lot of ideas are still coming into Python, like async IO or even the matrix multiplication operator, and even certain other uh, controversial operators, which probably are still being debated whether we should change the programming language. A lot of these discussions are interesting, but which leads me to think, what should we do as Python programmers, or should we, simply ignore those things, or should we embrace those ideas? And eventually, after thinking about this for quite some time, I realized that Python really is a multi-paradigm language. It is having ideas of functional programming, of imperative programming, of even logic programming to a certain extent. And if you're really keen on molding the language to your needs, you can actually do that because of all these paradigms built into Python. So that's what I'm trying to do here. I'll take you through each paradigm or each of the idea which comes from the functional world and see how it applies or it can be applied to Python. The first functional concept that I would like to cover is purity. Purity basically ensures that if you are talking about a pure function just works on the arguments that were passed to it and returns a value without changing the state of the world. In a very simple term, that's what a pure function does. So it is looking at how you can change uh, what is only or affect only what has been sent to it without affecting the world outside it. Let's look at the two-line function which is shown on screen, which is increment visits or increment visit underscore visit. It takes a dictionary P, just takes looks at the key visit and increments it by one. Now, the problem with dictionaries in Python is that it is passed by reference. So imagine you have a dictionary called say visitor count, and it was passed to increment visit. Now visitor count might be tracked as a global variable, or it might be used as an outer it might be used by the calling function in a number of ways. Now if you call increment visit, you might not expect that it will change the actual value of the global variable itself, and which is what is happening here. So the effect of a function is now leaking to the outside world, or in other words, it is not as pure or side effect free as a functional programming language might define it. So when I see a function like this, usually I try to treat the arguments which are passed into the function as constants or as not changeable, and as an improved version or changed version is shown below with 4 lines. I try to copy the arguments into another uh, temporary place. So in the case of a Python dictionary, you can create a shallow copy of the dictionary using the copy method. So p.copy here tries to create a copy of the dictionary into another dictionary called R, which is for short for return. And the return dictionary is now populated with the value of visit incremented by 1. So I'm not changing P, I'm just working on a copy of P, which makes it sort of side effect free. No matter how many times you call increment visits with no matter what dictionary, the dictionary is not modified, it's just a copy of that which is returned. So, what do we call this? Formally, this concept has a name. It's called idempotence. Basically, if a function assures that it returns the same result if it is invoked with the same arguments, it's called an idempotent function. So, how is this is an idempotent function is not actually a pure function. It is a sort of intermediate or a compromise between a completely pure and an impure function. So completely pure function could be something what is called a nullipotent function, which is a function which does not have any side effects. Uh, in my experience, a nullipotent function has a very limited value. Um, for instance, if you print something, it actually has a side effect, right? So you're affecting the outside world by displaying something. Or if you access a database, it is no longer a nullipotent function because you have access something which is not passed to it. if you have not passed the database itself. So the practical applications of nillipotent functions are quite limited. However, an ideal or a goal that I would recommend you to stick to is trying to create an idempotent function. And you a good example is that an idempotent function can calculate the value of pi and write it to a database. Now imagine running this a number of times. This function would always calculate the same value of pi, provided it's a very stable algorithm, and it would write to the same place in the database, and it will not create a different side effect. It'll always create the same side effect. So that is the property that idempotence is defined as. And in practice, you cannot always write pure functions, but I would recommend that you should aim for an idempotent function. In fact, this concept is what Celery documentation refers to. So Celery is a distributed task manager, which is commonly used with Django, and uh, the type of functions which are used as background jobs in Celery are generally defined to be as idempotent, because in case there is a failure, or if the job does not execute successfully, or if it throws an exception, or if the queue has some problem, for instance, Celery tries to retry or run the job again. And in that case, idempotent is a very important property to have, because if you cannot run a function a second time without the same side effect, then it becomes very difficult to qualify for it to become a good ideal Celery function. So, you might not be programming in a side effect free programming language, but hey, you can write functions which are idempotent. The next interesting concept which comes from functional programming is the concept of immutability that we referred to earlier. So, immutability is becoming more important in the case of distributed systems. If you have two clients accessing the same database, you have the problem of concurrency, and if you're going to access uh, the same table or the same row or the same shared memory location, it is usually controlled in a certain way that you cannot access, two people cannot access, or two clients cannot access the same memory location to avoid race conditions. And usually, this is done using locking mechanisms. If you come from the world of Java, you are more familiar with this. Like, you have to lock some shared resource before you access it. And if after locking somebody else tries to access it, it is considered to be locked, and you have to wait for that resource. Um, as many of us who have programmed in this paradigm know, this is not a perfect solution. This can lead to starvation, this can lead to race conditions, and many other issues. And this is not just a very a rare problem in distributed systems. Distributed systems are becoming more common than you imagine. For instance, web development or server-side programming is considered to be a distributed system, because essentially you're dealing with a system that is accessed by multiple clients simultaneously. So this is usually solved by minimizing the number of changes or mutations you're making by creating new copies or working with copies, etc. Um, I can actually show you this code example which highlights this issue. These 4 5 lines of um, pro code has been taken from a web scraper that I've designed in Django, and this is a very simple program which fetches a feed. For instance, it could be passed a feed ID, which retrieves the URL of the or enough details which include the URL from the model in this line, and it retrieves the page in this line. The page contents are copied into this attribute here called dot page, and then it's also the timestamp is also recorded in dot retrieved, and then it is saved. So what is happening here is that you are retrieving um, a, a particular instance of the model and saving it back. So you're basically updating the instance of the model. In SQL terms, you are updating the row of the table, and this is considered to be a mutable change in the sense that you're mutating an old value to a new value and destroying the old value. So the problem here is that if you have two, for instance, you had two clients who were accessing this particular function at the same time, what would happen is both of them would get the same copy of the feed, and then both of them would override them at different points. So this would lead to one of them losing the value which they saved. So depending on how much time the retrieval took and how updated the page is, this could lead to a very confusing state, which is dependent on the timing of the uh, saves. So this is a classic race condition illustrated through Django. Now, a common solution to this kind of problem is the usage of event logs or logging in general. Uh, Logging is basically a concept of, in very basic terms, is the concept of appending to a file. And in this case, we are using that concept in Django to create something called a feed log, which is a model which is designed for appending. So a globally unique identifier is created for the cases where you cannot for uniquely identifying an instance, and a sequence number is created so that uh, you get the latest sequence number. For instance, you got the feed objects the most latest feed object sequence number. You just incremented it by one, and you're just creating a new feed object and saving it there. So um you can actually see that if you go in ascending order of sequence numbers, you would go somewhat chronologically in time. And even if multiple clients try to save this, they might, even if they have the same sequence number, they might have different globally unique identifiers. And then, based on timestamp or based on some priority condition, you can choose to ignore one or two of these values and just allow one of them to be the canonical value at that point in time. So this is a common approach for solving concurrent access to a shared location, and it's called the concept of event logging. Another approach of solving this is using the concept of immutable models. In Django, what we do is we override the save method. The default save method is called in the end. Before that, we actually check if this model instance was created by checking its primary key. So in Django, if you have a primary key, that means that this model already had this instance. And if it's created for the first time, uh, in the sense that it's a new instance you're creating, it will not have a primary key. So if it is already existing, it will say that this instance is read only, you cannot change it. This is a good check to a runtime check, in fact, to have in Django. If you're not using Django, if you're just using plain old Python objects, you can still avoid the side effect problem by using a persistent data structure library. A very actively developed one is called Pysistence. That I've used in some projects. So Persistence offers persistent data structures, which are slightly different from immutable data structures. So, a persistent data structure does not change the old values. It, however, allows the changes in a data structure by, appending values to it, or uh, the new uh, uh, the new version or a copy of the existing database, the existing data structure is created, and we are looking at that version, and the old version is still maintained, which is what is meant by the word persistent here. The other meaning of persistent in computer science is that it is stored into a storage medium, but here it's used in a very specific context. Uh, if you look at the code here on how to use persistence, you can use, if you remember the old example of the visit dictionary, I'm creating a persistence dictionary called visits, with the visit counter being 0. So visits has a key visit, and if I try to mutate it by incrementing it by 1, you can see a not implemented error, and it gives you a clear message that you cannot set the value in a persistent dictionary or a pdict. So essentially, if you have to uh, change this dictionary, you cannot change it in place. You have to use a method called using. So visits.using will have a keyword argument called visit, and that visit will have the new value of visit. And if you look at this return dictionary, it will have the new values, which is basically that it's visit 1. So a persistent dictionary is a dictionary that never changes, and in the sense that you cannot mutate it in place. So if you look at the old value of visits, it'll still be the same value, and if you look at new underscore visits, it'll be the new value. So the old version or the old copy of the dictionary is still intact, and if you have multiple uh, people using this dictionary, they are still going to be working with the old value of the dictionary. Another lovely concept is the concept of lazy evaluation, which might not be intuitive or obvious at first, but it's a great concept as it's been extensively used in the programming language Haskell. Interestingly, Django also uses a variant of lazy evaluation. So if you use query sets, so query sets are basically a way of querying model objects. Uh, if you do something like take a model, do dot objects, do dot filter to that, do dot order by, do dot reverse, it will not execute them immediately. So in Django, if you do all these operations, each time it will not access the database and retrieve those values. It will only retrieve the values when you need it, which is called the evaluation of a query set. The evaluation of the query set happens only when you are converting it into a iterator or a list, for instance. And usually that happens once you have chained all your operations, and you have created a huge you created a long enough chain, and you finally want to use the values. So when you evaluate, that is when it hits the database, and usually hitting the database is a performance issue, as in it involves a certain time, uh, a, a number of cycles, a number of CPU cycles. So the strategy what Django is using here is, instead of hitting the database at every method here, why don't you hit it at only the uh, most appropriate time just once, and at that point in time you can bunch up all the criteria so that the return set is minimal. So imagine you're trying to hit the database when you say model.objects. That is the list of all the objects, that's all the rows in the table, which is a huge amount of data. And actually, not all that, you don't need all that data. You just need a very specific subset of that data, which ultimately is filtered or ordered or reversed, etc. And the smaller the data which gets returned, the more performant or the lesser time you'd need. So this is a very interesting strategy. You are avoiding computation by being lazy, and here it's considered a virtue because you're not using up unnecessary bandwidth. So, how can I use a similar concept in simple Python programming? Uh, Here is a class called conduit, which I found from Python recipes. Conduit is a very simple wrapper around an iterator, a normal Python iterator. As you would see here, the constructor is just assigning an iterator to its class attribute. You have a number of common functional methods here called filter or map or sort, and essentially they pass the iterator through a module called iter_tools, which is built into Python, and call the corresponding iter_tools method like ifilter or imap. And sort, as you know, sorted is already built into Python, so you don't need a module for that. And the last two methods are just returning the iterator or in the list form, whichever return value you would prefer. How would you use it? So you can use it on any iterator. So imagine books is a generator function or a list comprehension. You can pass it, you can wrap it around conduit. You can pass it, or rather you can chain methods to it, like you can call dot map, dot filter, dot sort, etc. And finally, at the end, you can say dot list. So dot to list will convert it into a list, and this would reduce the amount of memory that is used by your programs considerably, because iterator itself is a concept in Python which tries to reduce the amount of uh, memory that you would need. And lazy evaluation, as in general, is a strategy that allows you to work with almost an infinite amount of uh, data by just working on a window of the data at a time rather than loading the entire data into memory. Um, my favorite example is the example of web um, documents. So if you are processing a web document, there are two models, the SAX model and the DOM model of parsing XML or an HTML document. If you have a SAX parser, you have a parser that is designed to operate on events. So you have a stream of you're breaking down your read HTML document or XML document into a stream, and the stream might have different tags like HTML or body or H headings and paragraphs, etc. And the parser responds to each events by calling a method, and essentially you're parsing it as a stream, and you're not requiring the entire document to be in memory, as opposed to the DOM model or DOM model, which is quite popular because almost all the browsers implement the DOM model, and the entire document is parsed and stored as a data structure in memory. The disadvantage of the DOM model is that you need a lot of memory to save the document. Uh, Today, that is not a big issue because our systems or computers have enough memory to store those documents. But if you are in a resource constrained environment, like for example, you are parsing an IoT on an IoT device or in an embedded device, you don't have that much of memory. Then the other approach, which is a SAX approach, becomes more important, or only practical option at that point. Now, let's look at some basic principles on how you can create a data pipeline which enables lazy evaluation. Some of the steps that I would recommend are, break down your process into simple steps, like we saw in the case of Django, where you're breaking it down as order by or filter or sorted, etc. Um, you can actually identify what the simple steps of your process are, and the next thing I would recommend is allow method chaining. This is also called a fluent interface pattern. This enables you to, create a chain of methods, and lazy evaluation ensures that no matter how many methods are there in the chain, it will not affect the time which is required to compute significantly, because the actual computation happens only in the end. Then I would recommend you to work on parts of the data, which is essentially what iterators do, and essentially what I mentioned for SAX parsers, that you don't have to load the entire data into memory. Uh, the next recommendation I have is to use higher order functions. So a higher order function is a function which accepts a function as a parameter or as an argument, and hence the name of this talk. So functional programming languages use this concept a lot. For instance, if you're familiar with the map function, a map function takes another function which could be called for each member of a data structure, which it iterates over in sequence. The number of higher order functions you use gives you a lot more flexibility on how you can parameterize your computation, and helps you create a data pipeline much more effectively. And finally, think of the optimizations at the end. So, if this was Django, the optimization would be to create optimum SQL query that can be passed to the database for querying purpose. So, as the saying goes, premature optimization is the root of all evil. You don't have to think of how you can optimize at each method call, like how you can reduce the amount of memory which is done there, or how you can improve the speed. It's better once you have all the methods to be chained, and when the computation is actually happening, at that step itself, you can have an additional step of optimization, because now you have a complete view. Now you have the bigger picture of what the entire computation looks like, and that's the best time to actually do the optimization. The other principle, which I think is very effective, is static type checking. So, like I said, Python does have type checking, and today with Python 3, you have a certain uh, a level of static type checking as well. So, why is this important? Uh, what you see is an image of the Mars orbiter spacecraft, which um had crashed because of what was later identified as a programming error. And to be very specific, it was a type error which led to $1 billion mistake of the spacecraft crashing um, in space. So the error, if I'm to write it as a Python program, essentially can be seen on the screen here. Uh, the the problem was between two programs which were interacting with each other in the mission. Uh, the mission called Mars Climate Orbiter used another program to calculate its trajectory. And you can see that I'm using the new typing module of Python 3, and I'm creating two types: a Newton seconds type, which is a metric unit of impulse, which basically uses metric types like meters and um, centimeters, etc. And the old traditional English unit of impulse, which is pound seconds. And that these two units of measurement essentially measures the same physical attribute, which is impulse, but it is measured in two different units. And what I'm trying to do here in the main program is I'm calculating the impulse So this is the program which I was referring to, which is a separate program which the machine used, which actually returns in pound seconds English unit, and it returns fixed value, say 4.2, and this was used to calculate the navigation path, and which was um, a program which NASA themselves developed, and which was written in metric units, and it expected the impulse to come as an argument or as a parameter in metric units. And as you can see from this program, what is being returned is in English units, and what is being accepted is in metric units, and hence the mismatch. Uh, the actual mishap which led to this crash was between this mismatch. The calculated impulse was much lower uh, when it was considered to be in Newton seconds, whereas it was actually calculated in pound seconds, which led the uh, spacecraft from achieving the intended trajectory to successfully navigate. Now, the error here is, of course, indicated here that it is passing whatever was returned from the calculate impulse into the navigate function. Now, normally, if you run this program in Python, you would not see a single error. It will actually return the calculated value and say that it applied 4.2 here. But Python 3 offers static checking, and we have used type annotations here in this program. So if you notice, there's a type annotation for the argument, there's a type annotation for the return value, which is a string, and same here for the calculate impulse function. So if I use a third-party program called MyPy, which basically understands the type annotations and does static checks based on that, and call MyPy on this program, it clearly points out that argument number one to navigate has an incompatible type of pound seconds, and it was expecting Newton seconds. Now, this is exactly what a functional programming language would do. It would identify mismatches between types and raise them as errors. In Python, due to its runtime type checking or the duck typing, this is not really considered as an issue. But as you see, this can have a huge benefit when it comes to very critical programs. And even for normal programs, I would recommend you to use type checking to catch errors which are normally not caught. Another interesting benefit of type checking is through pattern matching. And you will see that pattern matching is quite essential to today's programming. So Python has this value called none, and if you have seen this error message, attribute error, none type method has no attribute method. I'm sure that you are intermediate or an experienced Python programmer. Almost all Python programmers have seen this error at some point or the other, because a method which was called on a value which did not have a value, which was having a value of none. And this happens a lot because in many cases, when something goes wrong in Python, the function simply does not raise an exception, it simply returns the value none. And the problem is not realized until very late, where sometime after you return the value, the calling function did a lot of other things and just tried to use this value, and it failed with this attribute error problem exception. Now, this is a lot of other side effects or other issues. You are really having this sleepless nights problem of refactoring Python code that you had written a long time back. Uh, any Python program that you have written, which is like fairly large and complex, uh, seems brittle to refactoring, because you really don't know whether you have changed, or if you are making a change or renaming a method, whether you have renamed it in all places, did you miss to handle a certain case when the value becomes none, or did you change the method used in other files as well throughout the project, or some play if you're creating a library, some program might be using this library. If it might be using a method which you forgot to rename, would it affect that? All these are because the onus of checking various cases or various situations of a particular type's value rests with the programmer. The responsibility is completely on the programmer rather than being checked by the type system. Let's look at how Haskell handles this using pattern matching. So if I have what you see here is a three-line Haskell function called show name. And if you have a Haskell function like this, which just takes a name, and the name could be a type which is called a maybe type. A maybe type essentially is a way of handling none or handling a value of nothing. So imagine a maybe type wants to show that it does not have anything, then it says that it is in a state called nothing. And if the maybe type has a value, it is in a state called just that value. So if you are passing a maybe type as an argument, you must handle the two states in which that maybe type should be. Uh, so here I'm handling the nothing state by returning empty, and if I get a just state, I return that name. So in any case, I'll return a string. Either it'll show this empty string, or which is the placeholder string, or it'll show the name. So if I pass just Arun, it'll show Arun, and if I pass nothing, it'll show return as empty. What I want to highlight here is that if I miss handling one of these states, if imagine I didn't have this line say nothing, return empty. When I run, even before I run this program, if I compile this program in Haskell, it'll complain that you have an incomplete handling of the states of your type. So this is exactly what we want in the case of other programming languages where it can silently ignore a value like nothing, and this is extremely helpful, and it is being seen more and more in new programming languages like Rust as a best practice. So it all is not lost. It's still possible to use this capability. There is a library called PyMaybe, and you can just install it using pip install. PyMaybe can handle by using a wrapper around any value by calling it maybe. And imagine you have a dictionary called person, and it has just one key called name, and it has my name. And if you wrap it around maybe, uh, and you just call a valid key, it'll return that valid key. And if you wrap it around and you call it with an invalid key, like address, and even if you call a couple of invalid keys and even an attribute of that, it'll return none. Because essentially what is happening here is again method chaining, and the exception is not being thrown at any point in time until you evaluate it. So the state is being passed on as maybe to the very end, and it leads to a very elegant handling of error conditions. So if you have an attribute at the end which says that or else, or instead of a method say or underscore else empty, it'll handle the none case, that instead of returning none, it'll handle that case, that what should happen when it returns when none of this returns a value. Should you still return a none value, or you should return a string value which is a valid value in this case, rather than returning a special value like none, which might fail with an attribute error. So PyMaybe is a great way of solving this. You have to handle this using method chaining, and you have to remember that exceptions will not be thrown here. So these are my recommendations in Python, which does not have extensive pattern matching. Try to avoid return none. If possible, you can use maybe as a pattern. If you think that it's having a lot of internal state, if you think that it's a class or a data structure which has a lot of internal state, why not use a state machine, right? You can keep track of what is the current state. You can transition from a start state to a ready state, and from a ready state to a sleeping state, and then to a finished state, etc. Uh, the concept of a state machine can be implemented, and it can be very clear at what state it is in by managing it explicitly. The other option is to let the library handle it, like I just showed using method chaining. And the final option is, of course, you can raise an exception rather than returning none, so that you can fail early than failing late, which seems to be the preferred canonical or pragmatic approach in Python. So let's look at the scoreboard here. Uh, does it mean that Python is functional? And we have a lot of ideas which we discussed. Uh, in terms of functional features in Python, purity is definitely not 100% implementable, and sometimes not practical as well. So, as I recommended, why don't you try for idempotency? The next characteristic is immutability. Like I said, Python is mutable by default. All values in or all variables in Python can be mutated. However, you can use persistence or some library which can use persistent structures and get around with this, or use log-based models or event logging. Closures, a very important concept in functional programming, and it's extensively used in Python as well for defining new style classes or decorators, etc. And closures essentially captures the variables at the time of defining a function, and makes it that enclosing context available as a part of that function. Extremely useful for functional programming and available in Python as well. So we are green there. The next is higher order functions. Yes, functions are first class objects in Python. You can pass a function to another function. You can create all sorts of higher order functions, and we are green there as well. Lazy evaluation is an amber because you really don't have the programming language does not support lazy evaluation out of the box, but you can implement lazy evaluation as Django query set successfully shows, or iterators show. So I think we are pretty good here, and by deliberate programming, you can actually make it possible. Pattern matching, in my opinion, a very important aspect of programming, and it's something that you can work around, but Python programmers must be extremely aware of this, and you can use static type checking tools like MyPy to ensure that you are doing some sort of static checking, but uh, pattern matching is definitely red. Tail recursion optimization is missing. It's more important if you're extensively using recursion, and rather than the iterative form of programming. But I feel that recursion is not as commonly used in Python, and you can probably avoid it and not have serious repercussions. So essentially, I would like to use the Batman's quote here. It's not who we are underneath, but what we do that define us. It might be that Python might not be having a lot of innate functional abilities, but you can actually use a lot of functional programming ideas. Like it happened to me, that you have been exposed to the ideas of functional programming, and you can actually use that effectively in any programming language, provided you do that quite deliberately. Thank you so much. So that's pretty much what I wanted to talk about in this presentation about higher order concepts and Python. Hope you enjoyed this. Let me know your comments on Twitter by tweeting me at Arox on Twitter. Thank you so much.